So this is what you see on your screen is basically the data science platform from IBM SPSS. Okay. So this is the tool is called IBM SPSS Modeler, the data science platform. Uh, and this allows the data scientist user to design and develop analytical assets, predictive assets, so on and so forth. Uh, and the use case that today we are going to deal with is the application of data science, machine learning, data mining, predictive analytics in the field of crime, right? So basically, we want to predict and prevent the crime and be able to, uh, proactively respond to the incident of crime happening in different places in a given jurisdiction, right? So let me, walk you through the data first, right? So this, okay. So before going into the demo, let me, walk you through the capability of the tool. So at the bottom of, the tool, the different nodes are organized in sources, record operations, field operations, graphs, modeling, database modeling, output, export, IBM SPSS statistics, Python related algorithms, Spark related algorithms, which will help you leverage the big data. And then you have IBM SPSS text analytics. So I will tell you what each of them, uh, palettes, the nodes which are organized into different palettes, right? The sources are basically, getting the data from the various different sources. It could be a database or a flat file, or even, the analytics server is about all, leveraging the data on the big data system, right? And then you have something like record operations and field operations. All these nodes organized in these two palettes helps you to prepare the data for artificial intelligence, or, it's something like, you get the data in the context of analysis. For example, it is the object of interest whose behavior you want to predict, right? And that object of interest could be either a customer, or it can be an employee, right? Or it can be a set of criminals, as in this example actually. And then it can be a number of computers, machines, so on and so forth. So anything can be object of interest, or a transaction in the bank, right? So on and so forth, right? So all these nodes in the record operations will help you to bring the data in the context of analysis, meaning that each record in your underlying data should, at the end, just before exposing the data set to machine learning, should represent that object of interest whose behavior you want to predict. For example, if the customer is the object of interest, then each record in your underlying data set should represent that customer, right? And then you have the full field operations, which the node will help you to, do some kind of calculations, right? For example, if you are wanting to predict the behavior of a customer, then probably the disposable income would be a very interesting thing to look at. And somebody who has, 1 lakh of income, and family member maybe less or more, depending on that you can calculate, the disposable income, so on and so forth. And for doing some understanding the intrinsic relationship between the various variables, you have nodes organized in graphs, which you can visualize, you can use to visualize. Now then comes the modeling basically, right? So depending on what is the kind of analysis that you want to do and predict the different business outcomes, you use one of these nodes to predict the outcome. is to push the analytics where the database engine is, and then you can visualize
Alok, your voice is breaking in between here.
Vishal.
Yeah, now it's better. Your voice was breaking in between actually.
Okay, okay. This is better now, right?
Yeah, much better. Alok, the same problem. Lata, if I am only facing the problem, or you are also not able to hear him?
Yes, yes, there is a slight disturbance. So his voice is going down and up, down. Yes, there's a crack. I mean, it's going in pauses, Alok.
Not audible, Alok.
Is this okay?
Yeah, now much better.
Okay. Now, so what I was saying is that there are some Python based and Spark based algorithm as well, which is out of the box. You don't need to have write even a single line of code, right? Which you call as an API in open source tools. Uh, s- and then we have the text analytics from SPSS, where you have the text link analysis and text mining, where you extract the terms and the concept from the underlying data and combine with the structured data to, enhance the quality of the model. So all in all, and from the functional capability, it gets the data from the sources and consolidate them together and make it consistent for make the data consistent and consolidated from the analytics perspective, and then expose it to the modeling to predict the outcome, right? So that is the whole capability of IBM SPSS modeler as a data science platform, right? And it is built around the crisp DM methodology, which you see on the bottom right hand bottom pane. You see the crisp DM, which talks about the 6 different phases of a data science project, which is called business understanding, data preparation, modeling, evaluation, and deployment. In the business understanding, you translate a business problem into a data science problem, and in the data understanding phase, you go back and see that if the data related to the outcome that you want to predict is being captured, and then you prepare the data, which consumes almost the 80% of time and effort, which are organized in the record operation and field operation, as I said earlier. And then it's all about the modeling thing. It allows even the novice user to be able to prepare the model, right? So as you can see in the bottom pane here in the modeling, you have auto classifier, auto numeric, and auto cluster. So all these are the three different kind of the models that you can build in here, apart from forecasting and apart from the forecasting algorithm, right? So now you can use one of these depending on what is the kind of outcome that you want to predict and what is the data type of the target variable, right? So auto classifier will classify, run through 8, 9, 10 different classification model and survive the three best, which you can use to ensemble or amalgamate them together to take advantage which are which misunderstand so on and so forth. Model and the quality overall model. So then he is the user will use those who are expert use the different algorithm. I started features what uh, the features features because have more ways to train the model. Right? Uh, this which also happy who are to be expert in the data science field as such, right? So overall, this is the very brief. This is the functional capability of the data mining workbench from IBM SPSS offering, right? Now let me quickly go to the use cases that I have for the crime prediction and prevention, right? So this is the data set. This is the node that I bring in from here, the sources, and drag and drop here and specify where my data is coming from. And I say that, okay, go to that folder and it is in a flat file. And let me show you, the whole data. So there are some 662 different crimes in crosstown uh, city. There are some 662 cases. If you see up there in the outcome, uh, right? So you see, the crime reference, the time and location information about that crime. And then there are different features of the modus operandi or the method that was used to commit that crime, right? So on and so forth. So, and then you also have, the data related to the classes, right? Or the property that was damaged or stolen, right? Starting after, the MO infera, right? So basically the property P is for property and audio, AUD. AUD is basically the suffix for that data element, right? So let me show you what are the different data elements that we have here, basically in different groups. So you can see the other screen on my on your screen, Vishal.
Yeah, look, can see.
This is basically a document. So as you can see, the description of the field, all the data, the field are, there is a description. So the first group of the columns, right? Crime number 2, the grid reference is all about the reference to the crime and time and places where the crime was occurred. And then we have the modus operandi, right? So method of entry to premises, point to entry of to premises, so on and so forth. So these these are the different methods of committing the crime, that particular crime in the record, right? And then you have the property stolen or damaged. P ought to P, you know, S, STR affirmed. That means the street furniture damaged. Right? So these are the various different categories of the property that was either stolen or damaged by the perpetrator of the crime. And then the head office of the UK police gives some kind of, to basically categorize a specific crime as either burglary, theft, uh, so on and so forth, right? And then you have some of the derived fields like hour of the crime, day, number, right, in the month or in the week, right? Uh, that you see at the end of the day, there are 662 different crimes, and each of the record basically represent a specific crime which has got the reference number and the other data that I walked you through just now. Okay. Now I move to the other thing. This we have shown. Now we'll do some kind of exploratory data analysis or graphical analysis to understand the volume of the crime in different location, method of operandi, so on and so forth, right? So if I run this, I can see at the short description that was given by the head office itself for each record. We see that the most crimes are around the burglary in the dwelling area, the residential area, the second row. Can you see the graph, Vishal?
Yes, we can see it. Yes.
Right. So there are 99 instances of the crime against the burglary dwelling and theft from the person, pickpocketing basically, right? Mm, they are about the 98 cases. And we are also having some use cases which we will use in downstream analysis, the burglary in the non-dwelling area, right? So basically it is comparing the burglary dwelling and burglary non-dwelling areas in other streams, right? Predictive streams. Similarly, if we will, see in some kind of map format that what is the, distribution of the different crimes. So as you can see, grid X will represent, excuse me, the south. This is something like the map, right? Which, the lower portion will show you as the north one, and the grid Y will show you the north area of the city, right? And on the on the left hand side of this will something like on the east of that city, right? So this is not exactly on the map, but because this is the grid X and grid Y that we are representing, right? To the cross section of different locations in the city, right? So this is just the representation of the map on a graph, right? So this also shows you, which part of the city or which area of the city will have which kind of, so if the certain area has got the propensity for a specific type of crime, for example. So if you see in the center, what do I say? What is that crime? Okay. So actual bodily harm, right, ABH, will have, the more of them in the central area. Burglary of dwelling is spread all across the city, basically, right? So on and so forth. So basically, it gives you overall the idea about, if certain area has got propensity to a specific kind of crime, right? So that understanding it gives you. Okay. Now I will say if it has got certain relationship with the month of the year, because certain type of crime has the propensity to occur in a specific kind of month. And if you can see in the month of June, we see a spike in the number of the crimes, and so to say that the theft from person or pickpocket has the highest number of occurrences in the month of June. So far, so good? Or you have some questions?
Yeah, works for us.
Okay.
We have got, yeah, we've followed it. Yes.
Yeah. Now I will show you. Similarly, we will do different kind of analytics or visualization on the top of the data to understand if there is certain things that are driving the crimes, right? Or certain attribute in the data has got certain propensity to occur together, so on and so forth, right? Basically, the whole point of doing the visualization is about understanding the propensity of the specific type of incident occurring in certain places. So I will not execute each of them. Just to give you idea, I have executed 4 or 5 of them. Now let me go to a very uh, somewhat advanced topic, right? So basically, we are wanting to group together a number of crime, uh, which was given a category called burglary dwelling by the head office, right? So if I say short description is equal to burglary dwelling, right? So I get the data from the same file, right? And filter that data, right? So I am now looking at only the data which are burglary dwelling, categorized at burglary dwelling, right? Now, what I do is I cluster them together. When I say cluster, it means that I want to group them together so that they are close enough with respect to modus operandi and time and location. These are the two different approaches that I have taken here, right? Now, as you can see here in the filter node, I have, deselected all the other columns except for the columns which are related to time and locations. Okay. So based on time and location, I want to identify which are, the different, crimes or the incident that are close enough with respect to time and location. Now for that, I use the Kohenen network, which basically groups the record in the underlying data so that there is homogeneity within the group as much as possible and heterogeneity between the groups. So if it has formed, say, for example, 5 groups, then between the groups, there should not be proximity of the record in some sense, okay, or in any sense, right? So that is the whole idea of grouping the data so that you can plan the direction of your investigation, right? So basically, it is the whole idea is to group them together in a way that you can approach similar kind of incident in certain fashion, right? Or you have some course of action formulated on the basis of the different attributes that you have about the crime in that group. So far, so good. Did I explain the idea behind this? Somebody say yes, no.
Yes. Yeah, that's fine.
Now, so what I do is I take the modeling thing, and there is this Kohenen network, which again is a clustering technique. I take it and put it uh, on the stream here and execute this. As a result of which I get the different clusters represented by x is equal to 0 to anything, x is equal to 1 2 3 4. Similarly, y is equal to 0 1 2 3 4. So basically, on a two-dimensional plane, the data is basically passed through and compressed in a manner that it can be represented on a coordinate thing, right? And then it shows you for the comparison of the distribution of the uh, overall population, right? So if I have the data around this is 365 days here, so the day of the year, right? So basically the first 100 days within that cluster x, this is the name of the cluster, x is equal to 0, y is equal to 0. The distribution is like this. The dark one is basically the distribution of the data within the cluster as compared to the entire population, as you can see as the graph in the background, which is not dark, right? So on and so forth. See, the whole idea is to from these many clusters, I select and generate a node from here called select node. So if I say, for example, I select um, this and this, okay, these two clusters, you can see my selection that I have selected x is equal to 0, y is equal to 0, and x is equal to 0, and y is equal to 4. For certain reason, I have selected these two. Then I say generate the filter, the select node. So basically, I will select only those records which will fall in these two clusters. Did I say myself? So as you can see on the canvas, it has generated the select this thing, basis on which it will select only those clusters into which these records will fall, right? So then I know that which are the different crimes that fall in a specific cluster of my interest, and I can focus only those crimes rather than focusing on everything. Okay. So similarly, I had done this and generated this select node, right? So as you can see here, I will show you one thing. At the end of the data, it will give you something. Edit. Node. Okay. Connect. Edit. Node. Connect. Okay. So at the end of the data, as you might see, it will show you that what is the cluster name, right, for each record. Now I want to select only those records which are belonging to specific clusters, right, so that I can focus on them, right, which are of the type burglary in the dwelling areas or the residential areas, right? So this gives me the time and location graph. Now these are the selected ones on which I need to focus, and it basically do the graphing with respect to month of the year 1 to 12, right? And then which cluster it will, time and location. Okay. So is that understood? Similarly, on the modus operandi thing, I will select only those columns which are related to modus operandi, but deselect the data columns which are related, capturing the data related to time and locations. Okay, and do the same analysis with respect to modus operandi, and see if similarly do the clustering using the Kohenen network, and using the modus operandi rule, whatever rule that it has extracted, right? From that, I will generate the select node, which will satisfy this condition of the cluster, which I have mentioned here, right? Which was generated using the interactive graph that you had seen on the clustering technique here. Sorry. What happened? So far so good. What is going on? Oh. I think I will have to kill this. Hi team.
Yes, Alok.
Yeah, so I think it looks like it has hanged. The software has hanged.
Oh,
So I don't know. So far, so it was good enough.
yes.
Okay. Let me force kill this actually. How do I do this? Okay. So we were where? Here now. So demo 2 we had already seen, right? Okay, so in demo 2 we had done this, the clustering or grouping of the different incidents, right? In a way, with respect to time and location and modus operandi, to be able to focus in certain a specific group of the crime, right? So that was the whole idea. Do you have any question related to this SPSS stream?
As a tool, Alok, I mean, we may have to do it ourselves to get into this kind of detail.
No, you
So,
don't have to do it, right?
okay.
Yeah, right. You don't have.
No, what I mean is, so, I mean, so as long as you're doing it, it appears to be easy. I
Okay.
mean, we're following, yeah.
The whole idea is to make it look simple and smart, not simple and
Yes.
stupid, right?
Yeah,
The
yeah,
whole
correct.
idea is that. So I make the things simple, then people think that it is simple.
Yeah.
Okay. Lata ma'am, you may have some question related to technique or something like that.
Uh, no, sir, not now, sir, because that was long back that I was doing this. Now I'm not into this, so I've
Okay.
not seen the tool for the past so many months. So I may have, this is kind of a restart for me. Thank you.
Okay. Similarly, we do it for the modus operandi for the burglary for non-dwelling area, right? We can do it depending on what was the result of the exploratory data analysis or the graphical analysis that we did in earlier demonstrations, right? And then, so this is the end of this. Then we have, what do you say? CPP demo, right? Now,
Alok, sorry for interfering here. My
yeah,
just one query is, I mean, we also want to know, I mean, see, apart this tool demo and you going about the use case and identifying, where what kind of crime is happening with respect to location, how to identify the burglar, I mean, is great. But what me and Shilpa basically would be interested is how to identify that a client has a data science use case. So, I mean, when we go to a customer and we get to know his environment and what kind of work he is doing or what kind of talent exists there, so how to tell him that, this is your case is the best one for data science. So that would give us a lot of.
this is what the data science is basically what I was doing it.
No, I mean, yeah, this is one of the use case. The thing is how to identify that data science can be applied to any kind of a situation. I mean, given a situation, we should be able to tell the client if, data science can be applied or it will be useful for them to buy a SPSS modeler. That kind of a scenario.
Right. So there is almost nothing that where you cannot use. It is only limited by your imagination, right? So there is no organization where you cannot use the predictive analytics, where you do the things repetitively, right? And measure and monitor the outcome of, the things that you do as a process. So basically, it is clubbed together into three different groups, right? One is about the people, and the people might be either a customer or I told you one thing that we probably did not notice was, organizing your data with the object of your analysis, right? And the object of your analysis means, or object of interest, basically, right? So the object of interest may be a person, an employee. That person can be either an employee or a customer, or can be a criminal or a group of scientists, and you want to predict certain behavior of those people.
Okay. Yeah.
Similarly, you say, okay, certain customer will respond to a offer, for example, right? Or a campaign that you might be running. Employee will attract, not attract, perform, not perform, right? So on and so forth, right?
Okay.
And then there are use cases related to operational efficiency,
Right.
right? For example, you have installed so many machines, whether or not that machine will keep running until certain time, right? Or you want to predict, what is the uptime of that machine. Now the object of interest has shifted. Now you want to, do analysis on the transaction and identify whether it is likely to be a fraudulent transaction,
Right.
so on and so forth, right?
Yeah,
So it
got it.
all, so see, it all depends that what is the key pain areas, right? Just doing the use cases by it is a sure way to fail, right? Because somebody is doing somewhere, and therefore I also need to do it. That is a sure way to fail.
Correct.
And therefore, you should engage with the customer in a manner so that the customer tells you that these are my key pain areas. When you go to insurance, then okay, you will say, how do I recover my, sorry, not insurance, the bank. How, that is the most painful area today. They are not able to recover the loan that they have given to different entities, right? Whether it is a retail loan or whether it is an organizational loan, so on and so forth, right? So it becomes an NPA, right? Or you can, predict even at the start of it. You cannot attach, the ill motives of certain person, of course, right? But you can always identify if or predict if certain loan that is being advanced is likely to become an NPA.
Right.
But if you have already decided that it will do, then you will put it something else in your data and then make it look like something else. You understand what I'm saying?
Yep.
So on and so forth, right? So
Okay.
it all depends. And if I also narrate, I don't.
We are not able to hear you again.
It started again. Hello? Can you listen to me?
Yeah, now we are able to hear.
But why it is always the one-way problem? I can hear you, but you cannot hear me.
Not sure, Alok.
Okay, anyway. So to if you are doing certain things on a repetitive basis and you monitor the outcome of that, right, which you can classify as C1 and C2, or maybe C1, C2, C3, or certain number, you did something, as a result of this you generated certain revenue, for example, or give you the best case use case, right? You go and sell your product day in day out, right? Say yes or no, otherwise I will not know you are there with me or not.
Yes,
Okay?
yes. We'll
Yeah.
we'll tell you if you're not able to get it. Yes.
And then you have so many opportunities, right? And these opportunities in the pipeline will either close as a win or as a lose. The reason for losing the opportunity could be anything. That is not the point. The point is the binary outcome is either you lose or you win. Historically, you have won so many and lost so many. Using that data, you can do the training part and then be able to predict the outcome of the the opportunities which are there in the pipeline. You understand what I'm saying?
Yes.
Right. So such are the use cases that you do on the repetitive basis, and outcome of which you can basically capture, right? And then train a model, learn from that past, and apply it to the current cases to understand what your future is like.
Yes. Got it. Yes. Yes, Alok.
So such are the patterns to, you know, are the use cases in the domain of data science. But the whole idea was to tell you more on, you know, the use cases surrounding the uh, crime prediction. Rather, the idea was not to give you, you know, the how the tool works, but I started with that because I just wanted to give understanding of what the product is capable of doing, so that your mind doesn't go off the way, right, and ask other unrelated question.
Yes, got it.
I was just limiting the scope of the discussion, basically. Okay. Similarly, we have some text analytics. If you can see, we have underlying data where the log of, you know, say for example, something like FIR, right? So in the log book, the officer will note down whatever information that he can gather from the place of the incident, right? Can you see that data, LOG? But this one is hard to, you know, get anything from in there, right? So you need to, you know, kind of convert that data in a tabular format, right, into such format as this, so that it is understandable to you. Then what you will do is that you will join this data with the structured data and then predict something, right? So if you can see, I have added more columns to this data, right? So basically I have extracted the terms and the concepts from the each record, right? And then if say that category under location was it something like that in the underlying data or not? Windows of vehicle broken, black bag stolen. So there is no mention of location as such. You understand what I'm saying? Whether it is commercial area, dwelling area, or whatever, but of that there is no mention in the law.
Correct. Adding more properties to that record.
Right. So on and so forth. Now I take the outcome of this and combine it with the other structured data and be able to predict it, right? Now let me open the other. Now this one is the raw data, as you can see on your left hand side on the canvas, right? Weather data, city events, right? Crime, officers log, all I put them together, right? As you can see here, I've taken all of these data, right? Merge them together and do whatever steps for the data preparation here, right? Weekly sum, monthly sum, Excel out. So all of these steps that I have done to arrive at this data set, which I will use for further analysis. So I will not work on the raw data, but the data that was, kind of enriched, right? So that it is ready for, as you say, IA, there is no AI without IA or architecture for AI. Basically, I bring the data together, make it consistent, and consolidate from across the different sources so that it is ready for doing whatever analysis that I want to do. So far, so good? Okay.
Yes, yes.
Okay. Now, what I do, and then is case, I do the modeling now on the top of that. Now, as you can see, I don't know which I have used the data for modeling. I had generated that data set and made it ready for the machine learning, right? And then I filter the factors here, set alert level, and filter factors, okay, using the feature selection, right? So not all the columns that I generated by enriching the data will play a role in predicting whatever I want to predict. And therefore, I need to do this feature selection. And then as you can see, there are data elements which are left out by way of looking at if there is association of individual columns with respect to the target variable. So far so good. I come out of that and then I use the auto numeric. I don't know which one is good enough, and therefore I take the auto classifier from here, okay, and put it on the canvas and connect it. And as a result of execution of this robbery flag, right, it gives me the three different models, three best model. By after running some 8, 9, 10 models, and it's according to the underlying data, right? Whatever the relationship is. C 5.1 is able to describe the variability under the data far better than any other model. Okay. But that also can be a case of overfitting or something like that. So that is a matter of further investigation, so on and so forth. Right? So I have done the modeling part also. Then I do the forecasting part. So you have done the clustering, you have done the classification. We will also do the association. These are the different categories. There are only 4 or 5 categories, right? Classification, clustering, association technique, and then forecasting thing. So I want to forecast what could be the number of incident that can occur in future time, right? For me here, anything beyond December 2010 is future time of reference. Okay, that is the way the data is, right? And then I forecast this for the next year, all 12 months. And then as you can see, river like structure, which is basically is the upper control limit and the lower control limit, defining that, right? So 95% of the chances, depending on what level of confidence that you decide, right? So 95% of confidence means type 1 error is 5%. And therefore, you can say that with confidence 95%, that your forecast is correct. So good.
Look, I'll need to log off. I'm getting a call. I'll need to log off.
I think, you are the only one on the call.
No, it's me and Lata.
Yeah, but I have a call at 4:15. In the interest of time, I'll be there, but I'll have to log off 4:15. Hello.
Are you there, Alok?
I can't hear him.
Sorry, I muted myself actually. You were saying that you are wanting to go, right?
Yes, I have a call at 4:15.
Okay, okay.
And I also need to log off, Alok.
Okay, no problem.
We can
But
catch.
yeah, so just one look that whatever you have generated with SPSS, you can put up on Cognos like this.
Okay.
This one.
Okay. So it will turn into a visual dashboard, is what you're saying.
It's not done. You need to develop this, right?
Oh, okay. Okay. Okay.
Yeah, that was generated in there.
Okay. Got it.
Yeah. ठीक है, so Silpa, you are saying right, you are going, right?